Okay, so here are your notes for 3-6. Like usual, we'll go over the learning targets, and then I'll get you some vocabulary. So by the time you are done with lesson 3-6, you should be able to graph a line when you're given an equation, no matter what the form of the equation. And your objective number 2, or your learning target number 2, is write an equation given a line. So these are just kind of opposite. If I give you an equation, I want you to be able to graph it. If I give you a graph, I want you to be able to tell me what the equation would be. Okay, so there's some vocabulary. A slope. There's lots of different ways to talk about a slope or define a slope. Technically, it's the rise over the run. Other ways you could kind of talk about that would be y2 minus y1 all over x2 minus x1. This 2 and this 1, they're subscripts, so they're small numbers, almost like the opposite of an exponent. An exponent is a small number that's up. A subscript is a small number that's written down. That's just to signify that when I have given you 2 points, which you'll need, there's one x and one y, the first x, the first y, and then there's the second x value, the second x coordinate, and the second y coordinate. Yes, the formula is normally y2 minus y1, and then x2 minus x1. Mathematically, if you switch these and you have y1 minus y2 and x1 minus x2, mathematically you're going to get the same answer because things will reduce the same, just so you know. Another way you might see it, it's going to look kind of sciencey, is the change of y, that's a delta sign. Usually one of those sides is a little darker, over the change of x. Those should be like triangles. Okay? That's another way to represent slope. Some things you need to know for slope. If you have a slope that goes uphill when you're reading that slope left to right, right? I know you could fight me and say, oh, well, it goes downhill this way and uphill that way. No, if you're talking about just going from the left-hand side to the right-hand side and it's going up, that's a positive slope. The reverse is a negative slope. Right? You read it like you're reading a book. Start at the left, go to the right. If you have a slope that is straight across, ooh, that's not very straight, is it? And that's a zero slope. And if you have a slope that goes straight up and down, again, not very straight, that's undefined. Okay, and I can show you mathematically why that would be undefined. If your slope is the rise over the run, this slope goes up and down quite a bit. So you could put whatever number you wanted to. Let's just put a 10. You could put 100. You could put 1,000. But the over, this line never goes over, right? Here I could say, oh, it goes up 1 over 1, up 1 over 1. It never happens to this undefined line. So I would have a 0. You can't divide by 0. That's why it's undefined. If you put 10 divided by 0 in your calculator, it would come out undefined. So that slope technically is undefined. Slope-intercept form of an equation is just that. It's an equation that gives you the slope, right? So it's mx plus b. Your slope is the m, and the y-intercept is the b. Okay. Move things here just a little bit. Hoping some of these words are a little bit familiar from Algebra 1. Okay, your next one is standard form. So again, it's an equation of a line. That's a capital A, x, plus capital B, y, equals capital C. Unlike slope-intercept form, where the m and the lowercase b represented something, these are just coefficients. Okay? Some rules to standard form, right? Normally we think of standard form as a certain way that everybody's going to write an equation. That's true for standard form. If you're going to do standard form, you need to know that A, whatever number A is, has to be positive. If it's not, you need to multiply the equation by a -1, changing all of the signs, including the sign on A. A, B, as well as C need to be integers. No fractions, no decimals. Again, you need to multiply through to make that happen. Okay? The last thing, A and B cannot both be a 0. If A was a 0 and B was a 0, this whole side would be 0. It wouldn't be a line anymore. It would just be a number equals C. Alright, your point slope form, I'll change colors because I kind of know I went over a little bit. Point slope form is going to be Y. I'm going to keep different colors. So this is what I'm going to try and do. There's lots of weirdness going on here for this form of an equation. I'm going to say Y. That's always going to stay a Y. The next thing, minus Y1. That Y1 is going to change. You're going to actually have a number there. Okay? And a set of parentheses will equal X minus X1. So, okay? Okay, so you also need, and this will actually be a number, your slope. And you can have the slope on either side of that set of parentheses. Alright, so just so you know, M is still your slope. And then your Y and your X will be the Y and the X from the coordinate, from the point. Okay? An intercept, either X or Y, is where your line that you're graphing where it crosses the axis. Okay, so if it's an x-intercept, it's where it crosses the x-axis. If it's a y-intercept, it's where it crosses the y-axis. So if that red line is the line that you are graphing, this point right here is your y-intercept. And then this point right here is your x-intercept. And that's just because this is your x-axis and that right there is your y-axis. Okay. We can move on to some examples now. So example 1 is graphing lines in slope-intercept form. This is one of the forms I want to make sure you can do. Your first thing, if you're going to graph a line in this form, is to find the slope and the y-intercept. M is always your slope, and B is always your y-intercept. So here, your slope will be 1/3, and your y-intercept is 4. I'll do a little arrow so you don't think it's a negative sign. So my second step is to first put in my x-axis followed by my y-axis. Notice some ugly lines. We need to plot your y-intercept. This is y. My intercept is where the line I'm graphing crosses my y-axis. So I need to count up 4. 1, 2, 3, 4. And I need to make a point. And that's my first point, y equals 4. And I'm going to use the slope to come up with at least one more point. Slope is rise over run. So for my y-intercept, I have a rise of 1 and a run of 3, because those are my numerators and my denominators. Don't forget, if I wanted another point, here I would run out of room. I can also go down 1 and negative 3. There are two ways to think about that. I can either look at the line and say, oh, of course, if the line continues forever in each direction, my next point would be down and to the left. Or, algebraically, 1 divided by 3 gets me a positive number. It gives me positive 1/3, which is equivalent to negative 1 divided by negative 3. Two negatives would make a positive. Two different ways to write the same fraction. So up 1 over 3 would be the positive version. Down 1, negative, or left 3, would be where they're both negative. I cannot make one negative and keep the other positive. That does not equal 1/3. Okay? I need them both to be the same. I'm going to try and connect my points. And I should have a positive slope, and this is a positive slope. Going left to right, I'm going uphill. Okay, so if we keep going on these notes, take a second and do the quick check that follows and see if you get the same answers as I do. So pause your video. Alright, so on these, my y-intercept is a positive 5, so I'll start and I'll have my x and my y-axis. Oh my gosh, I'll try to. That's embarrassing. And then I'll go up 5 for my y-intercept. 1, 2, 3, 4, 5, and I'll make a point. I always start with my y-intercept. I get to choose where this negative goes, so I'm going to think of my slope as negative 3 and a positive 4. A negative number divided by a positive number would leave me with a negative fraction, a negative answer. So for my y-intercept, I'm going to go down 3, 1, 2, 3, because it was a negative 3. I'm going to go right 4, 1, 2, 3, 4, because it was a positive 4. I've run out of room both ways. If I try and go up 3, left 4, I've run out of room. Also, if I try and go down 3 again over 4, I've run out of room. By definition, you only need 2 points to make a line, so I'm okay now. This one is a little tricky. Theoretically, I could write this and I could say, okay, there's a 1 in front of the x, and I'm adding 0 to that, right? If I add 0, it doesn't change my equation, the value of my equation. There's my horrible x and y-axis, real ugly, and I'm sorry. And I'm going to graph this line. So my y-intercept is 0, so even though my axes are ugly, there's my y-intercept. And my slope is just a number, just a 1. To make any number into a fraction, I'm going to put it over 1. Every time it will be over 1. I did not choose 1 because there's a 1 in the numerator. It will always be a 1. So if I had a slope of 3, my slope, would be 3 over 1. Does not matter what's in the numerator, it's always a 1. Alright, so I'm going to go up 1, over 1, up 1, over 1, up 1, over 1. I could go down 1 to the left 1. I could continue this pattern technically forever, but we don't have that kind of time, so here we go. Alright, should be a positive slope. It is positive. Back here just to check, negative slope, negative. Okay, next example. I'm going to do slope-intercept form. It has slope-intercept, I'm so sorry, because it's not slope-intercept, it's standard form. So we'll go through and do that. So there's your slope, your standard form, right here. I'm just going to make a note that this is standard. I'm sorry about that mistake up above. So to get your standard form, the easiest way to graph it, number one, you can turn it into y equals mx plus b if you want to. Or, for a different way to attack it, you can find your intercepts. When the numbers are nice, as they are in this example, I prefer to find my intercepts. Remember, if you're finding intercepts, they're where your line crosses the x or the y axes. So let's say right here. If I'm talking about that intercept that I've made a point at, do you agree your y value is 0? Right? You haven't gone up or down at all. Here at my y-intercept, my x is 0. I've not gone to the left or the right. So when I'm looking for my y-intercept, x will be 0. So my y-intercept happens where x is 0. So I'm going to use that in my equation. I'm going to write something out here that you might never have to write again. Okay? I think you'll be able to see a pattern and therefore make this a lot simpler on yourself. So I'm going to say x is 0. So I'll have 6 times 0 plus 3y equals 12. And I'll just solve that. 6 times 0 is 0 plus 3y equals 12. 0 plus 3y is 3y. If I divide both sides by 3, I have y equals 4. That means that I have a point, 0 for x, y is 4. To plot that, oh my goodness, to plot that, I'm just going to go 1, 2, 3, 4 on my y-axis. Right? Y is 4, x is 0. We'll do the same exact steps for your x-intercept. But let's think about this for just a second. Every time I'm going to put in a 0. It just depends on where I'm putting it. To get my x-intercept, I'm putting a 0 in for y. 3 times 0 is 0. This whole term goes away, just like it did here. The whole x term disappeared. You're just left over here with 3y equals 12 to get your y-intercept. Over here, you're going to be left with your x-intercept, your 6x equals 12 to get your x-intercept. So x will be 2. Therefore, you have a point at 2, 0. And I know it's 0 because I created a situation, I'm sorry about that, I created a situation where that's going to be true. I made y 0, and I plugged that in, right? 3 times 0 would get me 0, plus 6x would get me 6x. That's where that 0 is coming from. So now I'll just plot that point, 1, 2. I'm not going up or down at all. I only need 2 points to make a line. There it is. Remember, in standard form, none of these numbers represent slope or y-intercept outright. Alright, so we can do the same thing. I'll let you kind of try those on your own. Pause your video and see what happens. Okay, so here, to come up with my x-intercept, I would have negative 2x equals negative 8. Divide by negative 2, so x would be 4. And my y went away because y would be 0, right? And 4 times 0 would just be 0, plus a negative 2x every time that pattern will happen. So 1, 2, 3, 4. Alright, try and change colors for you. So that was my x-intercept. To do my y-intercept, x equals 0, so I'll just be left with 4y equals negative 8. Divide both sides by 4, y will be negative 2. There's negative 2. And remember, these represent points, right? I made x 0, y is negative 2. Up here, I'm sorry about the colors, up there, I made y 0, and x came out to be 4. Okay, I need 2 points to make a line, connect them, and you're good. Next, to get my, let's keep the colors. To keep my x-intercept, I need to make y equals 0. If I make y 0, this whole thing is gone. So I have 5x equals 15, divide both sides by 5. X will be 3. That's an X. That's a really ugly X, but it's supposed to be X. Alright, so we could plot that. Oh, that line's much better. A little bit better. Okay, so on my X, I'd go over 3, make a point. That's a positive 3. Now I'll do my Y. So for a Y-intercept, X, oh my goodness, I'm sorry. X has to be 0. So I'm going to make X 0 here. If I make X 0, this whole 5X term is gone. So I'm left with negative 3Y equals 15. And I'll divide both sides by negative 3. So Y equals negative 5. And again, remember this is the point 0, negative 5, because I made X 0. Up here, this is the point 3, 0, because I made Y 0. Alright, so X is 3 is already there. Y equals negative 5. 1, 2, 3, 4, 5. I only need 2 points. There are my 2 points. Okay. Alright, so there's your graphing. Your next learning target is kind of going in reverse, so that's what we're going to talk about here. So above, if you are given an equation, you can make a graph. Here, I want you to write an equation if it goes through this point and has this first slope. So your first thing should be kind of to decide what you have for choices here. So what I mean by that is you have a point and a slope. Okay, so if you have that for a point and that for a slope, I would use, if it was me, point-slope form. So if you remember, that's y minus y1 equals the slope x minus x1. And I just chose that because I'm given a point and a slope, and I can easily plug that into the equation. Here's a y-coordinate, x-coordinate of the point. Here's my slope. I'll always start with a y. This is y minus y1. My y1 is 4. Because it's a subtract here, I'm just taking the opposite. That's a positive 4. I'm going to put negative 4 or subtract 4. Next would be my slope, which is 3. I'll always have parentheses. I'll always have an x. And I would have minus x1. My x1 is a negative 1. Minus or subtract a negative 1 would be a positive 1. You always want to change the signs. You want to take the opposite. So there's my equation. I can be done right there. It doesn't say do anything to it. They just say an equation. Try the quick check, and I'll give you a second. Okay, so this is the same thing. They're giving me a point and a slope. I would use that same form. So I would have y, always start with y, the opposite of my y coordinate. So they've given me a negative 4. The opposite would be plus 4. Equals my slope of negative 1 times x, and then opposite of negative, opposite of positive 2, so minus 2. And again, I just want an equation. And that's an equation. I can be done. Okay, moving on to the next example. You want an equation of the line if I've given you 2 points. I would attack this by first finding the slope, and then picking a point, and kind of going back right to what we did before using point-slope form. So to find the slope, I'm going to go y2 minus y1 all over x2 minus x1. Remember, if you were to put the first coordinate here and the second coordinate here, that would be okay too. My y2 is a negative 1. Subtract from the equation. My y1 is a 3. In the denominator, my second x term, my x2 is a positive 1. Subtract, because that's the equation. x1 is a negative 2. Negative 1 subtract 3 is negative 4. Two negatives, it's like I'm adding. So 1 plus 2 is 3. Whoops, let's write something different. So my slope is negative 4 over 3, or negative 4/3. To do an equation, I'm going to use the same thing I was doing before, and I can pick either of these points. I'm going to pick this one just because it's first. Positive 3, the opposite of positive 3 is a negative 3. My slope I just found is negative 4/3. And then times the quantity x, because it's always an x, the opposite of my x term, so plus 2, since it started out as a negative 2. That's my equation. They're not asking for a certain form. I'm just going to be done. Again, I'll give you a minute. Pause it for the quick check. So this one I would attack the same way. I'd find slope, which is, I'm going to abbreviate with m. It's y2 minus y1, so I would have negative 3, subtract 0, and then x2, which is 7, subtract x1, which is 5. So negative 3 over 2 is my slope. And here we go, just back to the equation. I'm going to choose this point, y minus 0. And I'm going to simplify that in just a second. My slope, which is over here, is negative 3 over 2 times the quantity x and the opposite, so minus 5. Talked about simplifying this. You just don't even need this. You can just have y equals and be done. So that's my answer. Okay, I'm going to talk a little bit about horizontal and vertical lines. This is the last part you have to worry about. Okay, so if you have y equals some number, like y equals negative 3, there's no x. There's only a single variable. That's important. When you have a single variable, your brain needs to go here. It's going to be a straight horizontal or a straight vertical line. If you have y equals, it will be a horizontal line, which is weird because your y-axis is a vertical line. So if y equals negative 3, you find the point where that would be true, right here. And if you think about it, this is another point where y would be negative 3. Sorry, that is a pain. And another point where y would be negative 3, which would be right here, and here, and here. I could continuously make points where y is negative 3. It doesn't matter what x is. That's the graph of y equals negative 3. Horizontal line going through y equals negative 3. For a vertical line, it's the same idea, just in reverse. Here's my y-axis. Here's my x-axis already drawn. If x is 4, 1, 2, 3, 4, x is 4 right there, x is 4 right there, and right there, all of these are x equals 4. Oh, that's a horrible, oh my gosh, horrible line. There it is. That's the equation, really ugly line. That's the graph of y equals 4. Your independent work is on page 169, 2 through 32. Just do the evens, 33 through 35, 39, 53, and 55. Like always, please let me know if you have any questions.